Hi everyone, this is Mrs. Snowback. Today we're going to cover Unit 3, Lesson 6, more triangle information. The first thing is called the triangle inequality theorem. And it says the sum of the lengths of two sides of the triangle must be greater than the third side of the triangle. And what I mean by this is, let's say I told you to make a triangle that has sides 2 inches, 3 inches, and 4 inches. Well, the two shortest sides add up to 5. 5 is greater than 4, so 5 is greater than 4. So yes, I could make a triangle, and it would probably look something like this: a 4, a 2, and a 3. My triangle would look kind of like that. But if I tried to use the side lengths 2, 3, and 5, imagine what's going to happen. I'm going to have a segment that's 5 inches, a segment that's 2 inches, and a segment that's 3 inches. And as I lower these down, trying to connect them to make a triangle, they're not going to touch until they're totally flat, 2 inches and 3 inches, then they'll meet in the middle. But if they're totally flat, that's not a triangle. So the two smaller numbers have to add up to be more than the third side. Imagine I had 2, 3, and 6. So if I have a 6-inch one, a 2-inch, and a 3-inch, these are never going to touch, right? There's going to be an extra inch in between them where they won't connect, and so you cannot make a triangle. Will you please pause the video and try A and B? See if you could make a triangle out of these given lengths. So part A, 6.5 plus 6.5, that's only 13. 13 is not greater than 14. So no triangle. These two do not add up to be more than 14. If I look at part B, remember you want to add your two smallest sides. My two smallest sides are 6.8 and 5.1. 6.8 plus 5.1, that's 11.9. Is 11.9 greater than the third side? Yes, 11.9 is greater than 7.2. So yes, we can make a triangle. How about this one? If you have a triangle and side PQ is 7.2 and side QR is 5.2, which of the following could not work for the third side of the triangle? So think about if we use 7. 7.2, 5.2, and 7. The two shortest ones would be the 5.2 and the 7. Do they add up to be more than 7.2? Yes, they do. So that one works. If I have 7.2, 5.2, and 9, which ones are the smallest? These two are the smallest. If I add them together, are they more than 9? Yes. If I have 7.5, 5.2, and 11, these two are the smallest. Do they add up to be more than 11? Well, they add up to be 12.4, so yes, they're more than 11. But are they more than 13? No. So the one that does not work is 13. A second thing to think about is, what is the range for a third side of a triangle? So for instance, if I have a triangle and it has side length 5 and side length 11, imagine this is a hinge at the corner, and I could, move this 5, I could close it, right? I could move it in and out both ways. And so I want to know, well, what's the range for the third side of my triangle? Like, how big could it be? How small could it be, depending on if I have it moved in or moved out? Well, the way to do this one, to find the range of the third side given two sides, is you take your two numbers and you subtract them and you add them. 11 minus 5 is 6, 11 plus 5 is 16. So the range of the side has to be between 6 and 16. But you don't want it exactly equal to those, or you're going to wind up, imagine if I had 16, 5, and 11, it would be a totally flat segment. It would not form a triangle. So the way that you write it, let me grab another color here, is you say it has to be greater than 6 and less than 16. And you use these less than signs to show the range of what the third side could be. It's between 6 and 16, but not equal to. Okay, so try part B. Take your two numbers and subtract them and add them. So when you subtract them, I think you get 5.4. When you add them, you get 13. So now think about the range for the third side. It has to be greater than 5.4 and less than 13. It has to be between those two numbers. And the third and last thing we'll talk about today is the Pythagorean theorem. The Pythagorean theorem is used to find a side of a right triangle. It only works for right triangles. And remember, right triangles have to have the 90-degree corner. Couple of vocab words. The two sides that intersect at that 90-degree corner, they're called the legs of the right triangle. And then the side across, this side over here, across from the 90-degree angle is called the hypotenuse. And the hypotenuse is always your longest side. Hypotenuse is always the longest side because it's across from the biggest angle. These two angles will be smaller than 90. So the Pythagorean theorem states this: a squared plus b squared equals c squared. Your hypotenuse is always your c. So in a right triangle, the sum of the squares of the lengths of the legs is going to be equal to the square of the length of the hypotenuse. Just remember that c is your hypotenuse. Let's try number 1. If we want to find the length of the missing side, side length AB, I can see I have a right triangle, so I can use a squared plus b squared equals c squared. The longest side across from the 90 has to be my c. So the 12 and the 5 are going to be the a and the b, and it doesn't matter what letters they go in for. So I'm going to go 12 squared plus 5 squared equals c squared. If I flipped the 12 and the 5 around, it would be fine. 12 squared is 144. 5 squared is 25. Add 144 and 25, and it's 169 equals c squared. Now we don't want plain old c. I want to get rid of, I don't want c squared. I want plain c. So what I have to do is take the square root of both sides. The square root of 169 is 13. The square root of c squared is c because they cancel out. The root and the square cancel out. Technically, you get plus or minus 13. You might have learned that in algebra, but for this case, you're not going to have a negative length for the side of a triangle, and so we just say positive 13. Take a look at part B. This one, the c is 10. So I can write 6 squared plus b squared equals 10 squared. The hypotenuse has to go in for the c. 6 squared is 36. B squared is b squared, 10 squared is 100. Subtract 36 from both sides. We have b squared equals 64. We don't want b squared, we want regular b, so we take the square root. And technically we get plus or minus 8, but we're not going to have a negative length, so we'll just say b equals 8. And it looks like I have a label of feet. Have you ever been locked out of your house? Well, Caleb's locked out of his house. The only open window is up on the second floor, 14 feet above the ground. He needs to borrow a ladder from his neighbor. Maybe his parents aren't going to be home for a long time, right? If he must place the ladder 4 feet from the house to avoid some bushes, what length should the ladder be? First of all, I'm assuming this is a 90-degree angle kind of down by where the bush is. And then I can set up a Pythagorean theorem. I can say 14 squared plus 4 squared must equal the ladder, so c squared. 14 squared is 196. 4 squared is 16. If you add those together, you get 212. Finally, we don't want c squared, so we take the square root. And I believe it's 14.56 equals c, and that would be feet. Now, is your neighbor going to have a ladder that's 14.56 feet long? Probably not. They might have a 14-foot ladder. They might have a 16-foot ladder. So if it's a little bit short, you might just have to hoist yourself up into that window. Or if it's a little bit long, even a 20-foot ladder, you might have to set that ladder next to your window and kind of sidestep in. But there would be a way. You could figure it out. That's it. Will you guys please try Unit 3, Practice 6. Have a great day.